What's up, my fellow colleagues? We're back once again with number 53, maximum sub array. This problem, definitely not an easy problem if you've never seen it before, especially considering the one way you can do this with brute force by just kind of literally doing the dot product of this entire thing. Even there, it kind of gets a little bit tricky. But even on this platform, you're going to run out of time, right? So how do we do this in a way where we can get this done and it not take 3,000 years, right? So given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. What does contiguous mean here? It means that each element follows one another, right? So if we're doing a sum, we can't take 1 here, 4 here, and 4 here, right? That's not what the problem's asking for, right? It's asking for what's the largest number that we can create using contiguous pairs of elements. So like these 3, or maybe these 4, or maybe not even at the front, maybe just these 2, or maybe all the way from the back, these 6, right? So how do you go about doing this, right? So whenever you see something that's like contiguous subarray, substring, subset, subspace, right, you're gonna want, or contiguous sub anything, you're gonna want to instantly think sliding window pattern, right? So what does a sliding window pattern do? So the sliding window pattern is just kind of an algorithmic mental model. And so it lets you do is it lets you solve problems like this, right? And there's a couple different versions of it, but this one just kind of helps you visualize or loop through this array as by visualizing it as a sliding window of k elements, right? In this problem specifically, it doesn't really give you a specific contiguous subarray length that it's looking for. So this one's going to be the dynamic sliding window pattern version. But as you can see, if we were able to visualize this problem as a sliding window, right, that would say, hey, wait, 1 plus -2, well, it'd be better if we just took 1 instead of adding these together. So let's just start here. And then it's like, wait, let's add -3. Wait, that's worse than just having -1. So let's just go to the next one. And so you go here, and you'd be like, hey, I mean, if we add them together, we're positive, we're at 1, but it sounds like you can just do better by restarting. So just start at 4. And so that's kind of what the sliding window pattern helps you do. So how do you visualize this array? What's the code look like for visualizing this as a sliding window, as a dynamic sliding window? So this problem doesn't specify length, so we're gonna have to use a dynamic version. So this version is gonna look like this to kind of give you a scaffolding, right? This one, if we take a look at the problem, right, we'll see that our array can contain negative numbers, right? But we're supposed to return the maximum contiguous subarray containing at least one number, right? But the maximum, if we take a look here, the best, right, that we can ever do, or at least the minimum. So if we take a look here, right, what we can do is we can say, hey, let's start at -2, right? If we ever go below 0, then we're going to pick items off the front of the window until we're back at a place that's better than where we were before. And so as we're sliding through, the end of the window is what's going to be the outer for loop, which is going to be iterating through, and then we're going to use another while loop inside to kind of dynamically change the front end. So with the dynamic sliding window pattern, you're never going to be modifying the end, right? The end window, the end half of the window is always going to be slowly marching towards the end of the sequential whatever you're iterating, right? And so that's important to note. When you're doing the modifications, what you're going to be doing is messing around with the front, right? And so that's going to make it a lot simpler when you're visualizing the logic. So a few things we can do. We can create max sum, which is going to hold the value that we want to return, the maximum contiguous subarray. We're going to create window start, which is going to be the starting index of our window. And if we're starting at the front of the array, then obviously our first starting point is going to be 0. And then we're going to do for window end in range of len nums, right? And so every time, once on each iteration, we're going to add, oops, and I forgot, this is our window sum, right? And so with this, you can see all the parts of the window. We have the index of where the window starts, so 0, and the index of where the window ends, which is also going to start at 0, right? So remember we said the outer for loop is just always going to have the window's end portion slowly marching towards the end, right? And then the only thing that we can actually dynamically grow and shrink is the front of the window. So we can slide the front up or back or keep it in place, right? And then the sum in this problem, since we were looking for the greatest contiguous subarray, largest sum for a contiguous subarray, our window contents will be visualized as this sum. That's kind of changing. And another reason the sliding window pattern is so great is because when you do the dot product of this, so when you go like, okay, we're going to take the first element, and then for that element, we're going to go every element in the array. And then for this element, we're going to go every element in the array, right? That's very slow. And you end up recalculating a lot of things that you could have just calculated once. And so what the sliding window pattern is, if we take the sum of these two elements, right, and we add this element, we can actually subtract, because our window start will be at -2, we can actually just subtract our nums sub window start, which is going to be here. And now our window will look like this, right? And so that's pretty cool, because what we do is we never recalculate elements, right? We have this window sum, right? And it's just always growing or shrinking based on how our window is growing or shrinking. So we never actually have to keep recalculating elements that we've already added. We just only ever add from the front or remove from the end. So what do we do, right? So in the beginning, we have to definitely add to our window, right? The algorithm just started. We want to add something to the front. I mean, we want to add the first element that's at the window end, right? So that's just going to be our first element, right? And so during our algorithm, right, if we ever reach a point where window sum is greater than maximum sum, right, what we want to do is we'll say if window sum is greater than max sum, which means our window contents have somehow become greater than our max sum, what we thought our best we could do for the max sum. So we've PR'd here, right? We've done better than we ever thought we could using window sum than max sum. Well, we're just going to update max sum then. We're going to say, hey, we did really good. Let's update, right? And then our other thing that we want to do is we're going to say, this is where we're going to dynamically slide the window up, right? And so if we start our window sum at 0, right, we know that the minimum we can ever do, right? Because if we ever run into negative numbers in the array, the minimum window sum starts at is 0. So if we're ever negative, if we're ever less than 0, it means we've added something from the array that has taken our value from a neutral point, which is 0, to a negative point, right? And that's not good, because our minimum best we can always do is 0. So if we ever get negative, it means we messed up, right? So what we'll do is we'll say while window sum is less than 0. So while we messed up, we don't know exactly where, but we messed up somewhere, right? From adding all these numbers in the array and having our windows, right? We messed up somewhere, right? And so we can kind of visualize this here if we take a look, but I'll write the code first. What we're going to do is we're going to say, hey, just remove starting from the window start, and then we'll slide the window start up, right? And then from there, if this loop finishes, we can return max sum, and this should be I think we need this right here. There we go. So the other problem here, right, is that if you're taking the max of two things, right, and it's possible, right, that the maximum for a subarray that's given to us, if we take a look here, it's possible for a max if there's only one element in the subarray, right? It's possible, right, that we could have to return a negative number, right? But if our window max sum starts at 0, then it's kind of impossible for us to ever return the answer they're looking for, right? So what we end up with is a problem where if you don't know exactly what's coming in your data set, you'll never actually be able to set this to a number that you'll be sure without a doubt that you'll always be able to get the number that's actually the largest, right? Because I could do -100 here, right? But what happens if I start at -100 just to say, you know, that one of the numbers in is -101, right? And even if I do 102, then it could possibly be like, or I mean, guess 99. It could possibly be something even different, right? So That's why we're doing negative math.infinity. And to visualize this, let's take a look here, right? So we have -2. Actually, it might be easier if we do something like this. What we're going to do is we'll take example test cases, and we'll do this one. And so basically what we'll see as we're debugging this, even we know it works, right? And that's good. What we can see, right, is how it's working line by line. So right now our maxsum is -infinity. Our numbers are this. Our windows sum, right, is 0, and we didn't initialize window end yet, so we're going to start. So window end and window start at the same spot. Well, let's add what's in window sum, and let's add what's at the end of the window, which is the first index, to our window sum. We have -2, and we say, hey, is our window sum greater than our max sum? If so, that's pretty dope. We're kind of looking for that, right? Turns out that's not the case. -2 is not greater than 0, so we're not going to change that. Wait, window sum greater than max sum? Oh, no, right. Okay, I have this in reverse, right? It's -infinity, my bad. We're going to say, hey, is our window sum greater than -infinity? It is, right? Because -2 is a lot less than -infinity. So we're going to update that there. And then we'll say, hey, are we less than 0? If so, that's kind of bad because we can do 0. We can always do our best we can do is always 0. So we're going to remove stuff, and then we're going to start iterating here. We're going to remove stuff, and if we take a look here, we'll see that our window start is at 0 still. So we're going to remove stuff till we're at least greater than 0. Greater than or equal to 0. I'm not including equals here, but it's the same thing. And then what we'll see is that we did pretty good, and our window start moves up, right? We're going to hop out here, and then window end is going to move up too. And then what you'll see is that right now we're at 1. Both are at 1 again. And so the same thing happened, and we're saying, hey, our max sum before was -2, but we got 1 right now in window sum. We haven't gotten that high before, so we're going to update. And you'll see that max sum updates. We'll say, hey, we're not less than 0 right now. We're doing pretty good. Let's just go to the next iteration. And then on this line, we're going to add -3. And so we're going to get -2 for our window sum, which is pretty cheeks. It said, hey, we did -1 before, and we did 1 before, and we're at -2 now. That's kind of bad. So we're not going to update our window sum. And then we'll say, hey, we're less than -0 right now, which is kind of bad. So we're going to remove elements from the window start, which is at 1, and our window end is at 2, until we're back at least to something greater than 0 or equal to 0. And then our window sum will go back to 0 again. And then this continues each time over and over and over again, sliding down each time. And then if we ever get worse than 0, then we remove it. And we keep going and we keep going and we keep going until you get to about right here, where we kind of keep PRing. My mouse is skipping. Oof. But yeah, we keep PRing, and then we keep going, and then right here we do the best we can ever do with the window sum, right? And there's nothing to remove here. And right now we're at our window end index is at 6, right? So we have like a few more elements left. And then we keep going. 3, and then our output is 6, right? So it's kind of like, you want to imagine this as, hey, we're always sliding down. Wait, we messed up. We're going to slide all the way back up until we're good again. And we're sliding down again. Wait, we messed up. We're going to slide all the way up until we're good again. And then what you find is, we'll just keep going. And we're like, hey, this is pretty good. And this is kind of the winning configuration here. And then we restart back here again. But this time, there's no way we could ever beat our window sum, which is 6. Or our max sum, which is 6. So that is maximum subarray with the sliding window pattern.